Hello everyone! Today we're going to solve the LeetCode Daily Challenge number 368, largest divisible subset. In this challenge we are given a set of distinct positive integers nums, and we should return the largest subset answer, so that every pair answer I and answer j of element in this subset satisfy answer I modulo by answer j equals 0, or reverse. Either multiple solution, we return any of them. So we have a few examples. With 1, it's understandable that 1 modulo for 2 and 3, so we can return 1, 2, and also we can return 1 and 3. With example 2, it's kind of the same. Even if we remove 1, 2 is moduled by 4. The same 2 also moduled by 8. So kinda there's no case scenario when we use 3 and 7, for example, or 2 is 7. We can imagine this situation as building a reverse pyramid to cross the river. So instead of kinda thinking in numbers, let's think in imagination. So you explore a magical river and you need to cross it using stepping stones, our numbers inside of our array. Though we have these stones, but they are not original. Each stone has a unique positive number written on it, for example 1, 2, 3. And we have magical rule. Our magical rule is such that we start from smallest stone, but the next line of stones should be at least twice, to be more precise, divisible by the next line. So that first line, for example, will be 2, the next line will be 4, and the next line can be 8, because 8 modulated by 4 and 8 modulated by 2. But for example, if we had 3, neither 4 neither 8 is modulated by them. So we will be forced to start with 4 if we don't have 1, we have only 3. So the goal is to find the longest possible path of stepping stones we can create following this rule. So for better understanding, we can imagine input a list of unique numbers, stones, output the longest possible path, so the longest way that we can create using these stones to cross the river. And the constraint, the next stone number must be perfectly divisible by the current stone number. To solve this problem, to find the longest path, we can use dynamic program. So we kinda split this solution in multiple subparts. First of all, as we use this idea of building pyramid, we will need to sort our stones, so sort our numbers. Next, we will count the explorer path, so any combination of this stone to make the path. Then we will also start from the first stone, as it pace. We have only positive integers, so we don't have minus, so we will start by 1, and as we all know, 1 is perfectly divisible any of element. So then we will extend and check if existing path each we can create, and we will start from the longest. We will start from the longest path, then we record this path, we start a new path, then update the longest path, this new path if it's bigger, and finally we will draw any longest path. In dynamic programming, we will resolve this by building the solution, extending smaller, already compatible paths, subproblems. Then we will store dictionary, we'll store our result in dictionary, this subproblem solution, and group them by path length. And by checking the longest path first and storing the results, we will avoid redundant calculation and efficiently find overall longest path. So we will start with sorting nums. using sort method. Then we will declare our result, which will be collection of the full dictionary list. Is our path and length of that path. Then we will make our start from number 1, nums 0, and our maximum length will be also starting from 1. After it, we will iterate for our stones inside of our array, starting from the first one, not 0, so it's second. And we will mark them if it's added or not. So if we add a stone or we didn't add stones, by starting it will be false. So we will use length, the next loop, in range, which will be maximum length 0 and -1, so that we will start already with our maximum so far find length. We'll make sure it's not 0, and we will decrement by each step, making by 1. So the next what we will do is check our path, and path will be in our results length. So for example, if our num is modular by path in -1 and it's equal to 0, then we can mark new path equal to path plus num and new length equal to length plus 1. After this, result will be updated to new length appended to new path. And lastly, we will check and ensure that our max length will be equal max length by using max built-in function and new length. After this, we can mark added as true and effectively break and stop counting. The next, what we will do, we will check if added. So if added true, we can effectively break this loop. And we go for next. If not added, then we will use rest at 1 and append num. And finally, we will return result, which will be max length and 0. So let's run the code. And let's pass a case scenario and let it submit. And it beats 100 in runtime. So the main ideas here, it's better understand the description, and it's kind of help to have like this story when you are exploring something path instead of just working with numbers. It's better to work with stones or other things. And of course, it's using patterns like dynamic programming to break the sub-problems really helps. So thank you for your attention, and if you have any recommendation or idea, feel free add them in comments. Have a nice day. Bye.